Welcome to today's deep dive. Our core mission for this session is exploring a really frustrating digital bottleneck that, well, honestly, you've probably encountered it a million times.
Oh, definitely. We all have.
Right. It's that dreaded blank screen you get while you're waiting for massive data sets to load. But today we're unpacking a surprisingly elegant architectural solution to fix it.
Yeah, and the source material we're looking at today is just fantastic. It's an article by software engineer Aaron Rose, published on tech-reader.blog.
Yeah, it's titled The Secret Life of JavaScript and NDJSON. And I have to say, the way he writes it's really unique.
It really is.
Yeah.
I mean, Rose takes this highly unconventional approach. Instead of, just giving us a dry technical manual, he actually frames the whole engineering problem as a narrative.
Which makes it so much more engaging to read.
Exactly. So we're basically dropped into this grand Victorian library in London. It's incredibly atmospheric, towering bookshelves, hushed concentration.
Look at the ultimate deep work environment.
Right, exactly. It's the kind of development floor where code quality is basically the unspoken religion, and craftsmanship dictates every single pull request. And in this setting, we follow two developers.
We've got Margaret, who is this seasoned senior engineer, right? Just arriving at her desk with her morning dark roast coffee.
Yep, and then there's Timothy, her junior colleague, who is, he's having a notoriously bad morning.
Yeah, poor Timothy. But to kind of set the stage for you, the listener, about the specific UI problem Timothy is trying to solve, let's think about a restaurant.
Oh, I like this. Okay.
Right, so imagine you order a massive multi-course feast for a large table. The kitchen essentially has two ways to handle this. Option A, they make you sit at an entirely empty table for over an hour.
Just waiting.
Just waiting. They hold all the food in the back until the appetizers, the mains, the desserts are all perfectly plated, and then they bring it out on one massive monolithic tray.
Which is terrible service, obviously.
Exactly. Option B is they serve you progressively. They bring the bread immediately, then the salads a few minutes later. It keeps you continuously engaged.
Right, because diners absolutely loathe staring at an empty table. And in the digital world, users despise staring at a blank screen.
Totally. It feels broken.
Exactly. Progressive delivery fundamentally improves perceived performance. And that is the exact user experience Timothy is trying to engineer for his dashboard.
But instead of a smooth, progressive experience, Timothy is just watching a waterfall of bright red text completely flood his console.
The dreaded red wall.
Yeah. And the specific error he's getting, it's a classic. Syntax error. Unexpected end of JSON input.
Oh, man, if every developer knows that one. And that error pinpoints the exact point of failure. But to understand why it's failing, we really have to look at Timothy's stack.
Right, so he's trying to pull down a huge payload, right? Like 100,000 user records from the backend database.
Exactly, 100,000 records. And to do this without completely freezing the user's browser, he's using the Streams API.
Which, the Streams API is generally considered the hero of modern front-end architecture, right?
Oh, absolutely. Historically, if you use a standard fetch request, you'd have to download that entire 100,000 record payload into memory all at once.
Right. You're loading that massive string straight into RAM, you call response.json, and then you just wait.
Yep. You wait while the main thread completely locks up, and then later, the V8 JavaScript engine has to run garbage collection on all that temporary data.
Which causes those massive, annoying frame drops.
Exactly. But Timothy actually notes to Margaret that moving to Streams eliminated the memory buffer for their text logs. Streams are purpose-built for asynchronous, high-performance delivery.
Right, because the API bypasses that RAM bottleneck by processing data in chunks as it arrives over the network.
Yes, it hands information over to the application immediately. But, and here's the crux of the problem. The data format for these user profiles is standard JSON.
And JSON does not like being chopped up.
No, it doesn't. When you push a massive JSON array through a network stream, the network chops it up into TCP packets and the network layer. It does not care about the application layer structure of your data.
It's just moving bytes.
Right. So it slices the JSON objects right in half, mid-string. Packet 1 arrives containing a name and like half an email address.
And then packet 2 has the rest of the email and the home address.
Exactly. So when the JavaScript engine receives that very first packet, it tries to parse it.
But a JSON parser needs complete mathematically valid syntax.
Yep. Handing it a fragmented JSON object triggers an immediate panic, hence the waterfall of red text.
It expects a deterministic structure, and it basically just gets a broken string.
Precisely.
But wait, I have to challenge the technology stack here a bit, because if the Streams API is this state-of-the-art tool, Why does a mid-string packet slice cause a catastrophic failure?
What do you mean?
I mean, shouldn't a modern stream reader be intelligent enough to recognize, hey, this is an incomplete object? Like, just buffer it internally and wait until the next TCP packet arrives to finish the payload.
Ah, okay. See, this is a really common misconception. We frequently anthropomorphize our development tools. We assume they have this built-in intelligence that just simply isn't there.
So the stream is basically dumb.
Well, a stream is fundamentally a raw byte conduit. Its sole engineering directive is to move chunks of data from point A to point B as rapidly as physical network latency allows.
Okay, so it's all about speed.
Pure speed. It has zero awareness of the payload structure. It doesn't know if it's transmitting JSON data or a compiled WebAssembly binary or a compressed JPEG.
Oh, wow. So the failure isn't actually the stream speed at all.
No, not at all.
The failure is the architectural mismatch between these chaotic, arbitrary chunks arriving over the network and the really strict, deterministic expectations of the JavaScript parser.
Exactly. That's a perfect way to summarize it. And Margaret, who's looking over Timothy's shoulder in the library, she actually validates his initial intent.
Right. She tells him his goal of rendering profiles progressively is the correct architecture.
Yeah, she's like, do not revert to legacy techniques. Don't go back to server-side pagination, which just adds latency on every click.
Or those massive debouncing functions that basically just mask the real load times.
Right. Timothy wants the browser to paint the rows as fast as the database can serve them, and Margaret agrees with that. But she points out he's fallen into a fundamental trap.
The boundary trap.
Yes. She takes a sip of her coffee and asks him a really simple but profound question. What defines the boundary of a complete object inside a standard JSON array?
And Timothy knows the technical answer to this. It's a comma separating the items or a closing curly brace.
Yep. But then Margaret pushes the logic further. She questions whether it's genuinely efficient for a stream reader to safely identify that correct closing brace on the fly, especially when parsing deeply nested, complex data structures.
Okay, see, this is where I would push back on Margaret's premise.
Oh, really? How so?
I mean, identifying a closing brace is just basic counting, right? You keep a running tally, you initialize a counter, open brace, add one, close brace, subtract one.
Okay, I see where you're going.
Right, and when the counter hits 0, boom, you found the boundary of the object. It's an O of N complexity operation. That shouldn't bottleneck a modern V8 JavaScript engine, should it?
In theory, you're right. But that logic only holds up if your payload is perfectly sanitized, uniform data.
Which real-world data never is.
Exactly. Real-world user profiles contain nested arrays inside nested objects. Like, consider a user's bio section that contains a string of free text.
Oh, right. Users can type whatever they want.
Exactly. What if a user typed a curly brace inside their bio? Maybe they pasted a code snippet or a text-based emoticon?
Oh, man, the counter would read that.
Yes. Your naive bracket-counting parser sees that character, decrements the tally, and falsely assumes the main object is closed. It would completely corrupt the execution.
Because the simple counter lacks structural context.
Right.
It has no idea the brace is trapped inside a string, literal.
Exactly. To safely count brackets, your parser can't just scan for characters. It actually has to reconstruct an abstract syntax tree on the fly.
Which sounds expensive.
Incredibly expensive. It has to track escaped characters, understand string boundaries, resolve nested hierarchies, all while attempting to process this chaotic fire hose of fragmented byte chunks.
So you basically end up burning all your CPU processing power just trying to find the edge of the data.
Right, which completely negates the performance benefits of using a stream in the first place.
Because standard JSON arrays are inherently designed to be parsed as a single monolithic block, the engine needs total structural context from the very first byte.
Exactly. And this brings us to the pivotal moment in the narrative. In this quiet Victorian library, Margaret steps up to a whiteboard, uncaps a dry erase marker, and writes 6 letters.
NDJSON.
NDJSON. NDJSON. New line delimited JSON. And this completely reframes the entire engineering problem.
It's a massive paradigm shift. She tells Timothy, look, the problem isn't the JavaScript parser, and it isn't the stream reader.
No, the problem is the format of the data itself.
Right, because if your goal is to stream data, you can't use a format that was engineered for all at once, monolithic processing.
It's like trying to force a square peg into a round hole.
Exactly. It's like if we contextualize this for a developer standard, JSON is like a tightly coupled software monolith. If you only deploy a fraction of the code base, the entire system crashes.
Because of all the unresolved dependencies scattered throughout the architecture.
Right, you have to compile and ship the whole thing. But NJSON, that's an architecture of independent microservices.
I love that analogy. Each service, or in this case, each user profile, is entirely self-contained. You can process and execute one without having any knowledge of the others.
It reminds me of like a massive multi-page legal contract versus a stack of independent flashcards, you know?
Oh, that's a great way to picture it.
Yeah, with standard JSON, you have to read the whole contract to understand the clauses. With NDJSON, you can read, process, and file away one flashcard at a time without needing the rest of the stack.
Exactly. And that represents the exact shift Margaret outlines. But to implement this, the backend server emitting the payload has to fundamentally change its behavior.
Right. The backend needs to stop wrapping the 100,000 records in a giant monolithic array with a single opening and closing bracket.
Yep. Instead, it needs to stream new line separated JSON objects.
So every single user profile gets serialized into a standalone JSON object. It's completely independent.
Yeah.
And then it's followed by a hard line, break a \n.
Exactly. And then the next profile is just written on the following line.
Okay, but wait. Transitioning to any JSON on the server, that doesn't actually alter the physics of the network, right?
No, the network is still the network.
TCP packets are still arbitrary, so the stream is still going to slice those independent JSON lines mid-string. And a fragmented string still crashes the parser.
That's entirely true.
So changing the format on the server doesn't magically align the network packets.
No, it doesn't. We still need a client-side mechanism to rebuild these lines. The network behavior remains identical. But Margaret explains that a new line character is a universal, unambiguous boundary.
Unambiguous is the key word there.
Right. It drastically simplifies how the client-side code interacts with those incoming chunks. Searching for a primitive new line character is fundamentally cheaper for the CPU than building a complex syntax tree to track curly brackets.
Okay, so how does Timothy actually build this in the code? Does he stop the network from slicing the data?
No, you can't stop the slicing. Instead, you implement what's called the accumulator pattern.
The accumulator pattern, okay.
Yeah, you establish a really lightweight temporary string buffer in memory. As the raw stream chunks arrive from the network, you don't even attempt to parse them.
You just hold on to them.
Exactly. You simply append them to this buffer. You're basically saying, I'm just going to collect these bytes until I see a stopping point.
So we're just waiting to open the box until we know a full item is inside.
Precisely. You watch that buffer using a highly optimized search method, like index of \n.
Oh, wow.
And the literal millisecond, you detect a new line character, with absolute mathematical certainty that everything preceding that character is a complete valid JSON object.
Because the backend guaranteed that format.
Exactly. So Timothy refactors his client-side logic to leverage this. He collects the network chunks, he splits the buffer at every new line character.
Right.
He slices off the complete string, hands it to the JSON parser, which now succeeds flawlessly because the object is whole, and renders it directly to the DOM.
That is so clean. And what does he do with the leftover fragments?
He just leaves any remaining incomplete fragments in the buffer to combine with the next network packet.
That is brilliant. It's so much simpler.
It really is. Now, the source material does highlight one essential detail in Timothy's implementation. He wraps all of this parsing and rendering logic in a try/finally block.
Okay, try/finally, not try/catch.
Well, he might have a catch, but the finally is the critical part here. In a streaming architecture, this is essential for production hygiene.
I mean, a standard try-catch handles a parsing error if corrupted data gets in. But why is the finally block specifically so critical for streams?
Because streams in JavaScript hold a memory lock on the reader while they're actively processing.
Okay, so it locks the memory.
Right. If an unhandled exception causes your function to crash, and you don't have a finally block to explicitly release that lock, the background process just remains active.
Oh no, so the garbage collector can't clear it.
Exactly. The garbage collector can't touch it. The stream just keeps pulling data into memory without processing it, creating a catastrophic memory leak.
Which will eventually just crash the user's entire browser tab.
Yep. So the finally block ensures the lock is released regardless of success or failure. It's a non-negotiable safety net.
Wow, it really is an incredibly robust, elegant architecture. I mean, we aren't forcing the stream to evaluate syntax.
No.
And We aren't writing some complex CPU-heavy bracket-counting algorithm. We simply establish a primitive, unambiguous boundary align break and build a lightweight accumulator to respect it.
And the resulting performance upgrade is profound. The article details Timothy's triumph as he finishes refactoring the component.
I can imagine the relief.
Oh, yeah. He hits refresh on his dashboard,
Yeah.
and the loading spinner just vanishes instantly.
Yes. The DOM begins painting the user profiles row by row. It pulls the records out of the stream and renders them flawlessly onto the screen.
No massive garbage collection spikes freezing the UI.
No blank screens.
And absolutely no unexpected end of JSON input errors.
That is huge. By acknowledging the architectural limitations of a monolithic data structure and actually respecting the boundaries of the data stream, Timothy achieved true progressive rendering for complex objects.
It really serves as a stark reminder. The most powerful engineering solutions often involve simplifying the underlying structure of the data itself, rather than adding layers of complex logic to manage an inherently flawed format.
Right, it completely changes how you look at the mechanics of the web.
It does.
Like, to you listening, the next time you load a massive web page and that DOM populates smoothly and instantly, row by row, there is a very high probability a simple new line character is doing the heavy lifting behind the scenes.
It's the unsung hero of the modern web. Standard JSON is fantastic for discrete payloads, but as datasets scale, its monolithic nature becomes a severe liability.
Because it requires total context.
Exactly. Total context is the enemy of streaming.
Wow. You know, if the definitive solution to this technical nightmare was to stop trying to ingest a massive monolithic structure whole, and instead break it down into single independent lines, it really forces a broader perspective.
How so?
Well, it makes you wonder what other massive unbreakable structures or processes in our daily lives are failing simply because we refuse to process them one piece at a time.
That is a fascinating way to look at it.
Let that percolate. Thanks for joining this deep dive.